I'm really excited to get to be here today. Since I started working on the Biodata Catalyst ecosystem, I've become very much like a champion of cloud computing, because one of the things that I care a lot about is the challenges of big data and how researchers can work with big data to get out of it what they want. There are some challenges with using cloud platforms. One of the challenges that we experience is that data sometimes isn't allowed to be transferred or is just too large to be transferred. So you have to use the data where it lives. This is also referred to as the analysis to data paradigm. But that's not super comfortable for everyone when we're starting out. We think of our data as an object that we want to bring to our home instead of having to go to where it lives. And so we often experience challenges with having multiple copies of data because we want to analyze it in one platform or another. And transferring data on cloud platforms can often result in data egress charges, or what I usually call data download charges. And then if we're using lots of different platforms, we might also experience just difficulty with understanding the billing. I know that many people, when they first start out using cloud platforms and cloud computing through the big infrastructure providers like AWS and Google Cloud Platform and Azure, which we'll be talking about today, the fact they have to pay for time on compute, it feels very foreign. I am a child of the 90s, and so I grew up paying for time in internet cafes. So it didn't seem too strange to me, but it's not always the way that we're used to using our computers these days. And that can be even more upsetting if there's lots of different billing to handle. So some of the 7 bridges and Biodata Catalyst powered by 7 bridges exists to try and minimize and mitigate these problems. We use this phrase a lot, using data where it lives. And as I said, in more formal terms, this is the analysis to data paradigm. It's become really crucial as the data that we're using has gotten so much larger. Not too long ago, it was actually easier to move the data to where the software was installed because the data was smaller than it is now, and installing software was a bigger pain. But containerized software is now more the norm. So installing software is easier and the data is bigger, so moving it is harder. BDC SV, Biodata Catalyst powered by 7 bridges, acts as a single pane of glass. It gives you access to the data and the software, and lets you very seamlessly combine data from different sources and operate on them where they live, but delivering all that to you in one interface. And so this means you can collaborate with your fellow researchers more easily. You can avoid and minimize data egress charges. And BDCSB provides a unified billing system. So even if you're operating in multiple different cloud locations, you're not having to manage purchase orders for all these different cloud providers. We just pass through the cloud charges in one invoice. So to make this a little clearer and to sort of explain what I mean by multiple cloud providers, let's talk about a use case. So here we have our imaginary Dr. Collins, who is working with collaborators and wants to work on co-analyzing clinical, genomic, and I should say imaging data stored in multiple locations. Moving all these files to a single place first, and then beginning the analysis would be ponderous. I'm sure a lot of us here have stories about giant data and the struggles that it imposes. But in my postdoc, we did a bunch of whole genome sequencing on Aedes aegypti mosquitoes, and that generated over 4 terabytes of raw data. And I actually spent a month just getting the FASTQ files like in a spot where I could work with them. So we don't want to have to spend time just moving bytes. We want to be working on the data. The other thing is these data are stored in different places. So let's say the imaging data is stored on an Azure, a Microsoft Azure cloud platform, while the clinical traits, the phenotypic data is all stored on a Google Cloud volume owned by another collaborator. And the genomic data is all stored on Amazon Web Services, where another collaborator has a volume. Getting these data onto the same platform to co-analyze them will incur data egress charges as the data moves from one platform to another. Dr. Collins, like all of us, doesn't want to spend weeks just getting files into place. So how can she start this analysis fast without resorting to having her colleagues snail mail her 8 terabyte hard drives? So one of the things that's important to remember is that big data only starts big. Ponderous data files should not move to the analysis. The analysis should move to the data. It's just a truism in bioinformatics that our raw data files are much larger than the information we need to derive out of them. We usually compute from big data down to smaller aggregated or summary files. The counts matrix from an RNA-seq experiment of over 250 samples is much smaller than 250 alignment files. The CSV file output of a fluorescent multiplexed imaging pipeline is a lot smaller than the images themselves. So rather than move the big data files, we want to process those files down to the inputs we'll use for the multimodal analysis. And then we only move those small files. The other thing is that all of these cloud providers typically provide some kind of cold data storage. And cold data storage means the data is kept in a highly compressed format. So, much like your -80 freezer in your lab, the data is frozen and has to be thawed and moved to an uncompressed format in order for you to operate on it. Raw data can be stored very economically in that cold data storage. And on BDC-SB, we have a file archiving system that moves those files to the cold data storage. So this is your first step, is think about how you can get those big data files into smaller files that are more manageable, but still have the information you want. And then you want to, either before or after you finish processing down that raw data, you need to determine the analysis home. So I'm suggesting 3 criteria to think about here. Think about the security of the location with respect to data integrity and protection, the cost, because all these things do have a cost, and just how comfortable you are with any given cloud location. There could also be other considerations as well. Maybe your funding body actually requires you to use one of these platforms, or maybe the data and the derived data are not allowed to be moved out of where they are. And part of the reason BDC 7 Bridges offers multi-cloud functionality is so that you have that flexibility in choosing where you do your work. And then once you've chosen that analysis environment and you've processed down your raw data, then you can move those smaller files to that chosen location. So this is going to minimize data egress costs because you're just not moving as many bytes. And it avoids duplicating those enormous data files in the transfer process. And that's particularly important when you have many collaborators, because the more people are touching a project, the easier it is to end up with different versions of data. So we have very recently at BDC 7 Bridges added Azure to the cloud locations that we have available. We have Google Cloud locations, AWS and Azure now. And you know, the location names have like a region on them. Don't worry about that. It's all the internet. The region doesn't really matter, but the location of the cloud does matter when you're talking about like moving files. I'm going to now do a really quick demonstration just to show you what this looks like. Oh, alas. Actually, I'm not going to do a demonstration because is anybody else having issues lately with signing in through the NIH? No, okay, it is going to work. No worries. Let me pull this over to my main screen. Yes, I authorize. So I'm going to change what I'm sharing real quick. So what you should be seeing now is my my sandbox project. This is the dashboard for my sandbox project, which is where I do a lot of my work. I'm going to create a new project and show you how you select which of the cloud locations you want. So at project creation, I went to the projects drop down and I'm going to click create a project. At projects creation, you have this option here for location. And anywhere on the BDC 7 Bridges platform, you see a little eye in a circle. That's a tooltip, and you can click it and usually get to documentation. I have 3 options here in my location. I can do AWS, Azure, or Google. So just for demonstration purposes, I'm going to pick Azure here. And then, of course, we have some advanced settings. Download restrictions are a new feature as well. So you can make it so that people cannot download anything from a project. I usually like to allow network access because it tends to reduce some of the weirder errors that we might get. And then I'm just going to create this project, and note that the location of the project cannot be changed after you create the project. But that's not a huge difficulty. You can create as many projects as you want. It's just a unit of organization, and files can be copied between projects. So this also will determine what kinds of instances you might have available in a data studio project. So when I create a new, say, RStudio analysis in data studio, I'll see only Microsoft Azure instance types available here. But the information, like the relevant vital statistics about the type of instance are right there in the name. So it's pretty easy to say, well, I'm going to need a lot of RAM, but not a lot of CPUs, so I can pick that instance. So that is the presentation and the demo.